Can you see my screen now? Is it okay?
Yes, I can see your
Okay,
screen.
nice. So, good morning, everyone. Thanks for joining our webinar session. And now we're starting with the general presentation of Synapse project. My name is Oleg Ilyashenko, and I'm presenting the coordinator of this project, National Research Council from Italy. So, let us go. Yeah, so the overall information about the project is as follows. So the acronym of Synapse is coming from an integrated cybersecurity risk and resilience management platform with a holistic situational awareness, instant response, and preparedness capabilities. Basically, we started 2 years ago in November, and we'll finish in this project next November. So it means about 3 years. We have 14 partners from 8 countries and about 800 and medium man months. Yeah, a big amount of work. And let's go to the overview of our partners. So from Italy, we have National Research Council, which is state-owned research organization and coordinating this project. From Germany, we have a company Framatome. We have from Greece company Dinekes, from Cyprus Cyberlytics, and from Greece again Karavias, and Insuretics from Cyprus. We have a couple of university academia partners from University of Malaga and University of Oslo. A part of that from Germany, company Aegis, from Greece Nodal Point, Eunomia, and from Switzerland Sphinx Technology Consulting, and of course we shouldn't forget about Maggioli IT Industry, which supports us mainly in dissemination and other project types of activities. So briefly introducing the Synapse, it's worth to say that the main goal of the project is to design, develop, and deliver an integrated cybersecurity and resilience management platform with very, let's say, complex situational awareness, instant response, and preparedness capabilities, trying to address the challenges of the cyber assurance and having the demonstration of use cases evolving several pilots. Couple of them you will see later today the webinar. So basically, if we're talking about the Synapse platform, we're thinking about the reactive instant response process, which will minimize human involvement, because human is the source of errors, most of errors in the safety and cybersecurity industry. Of course, due to the rapid extension and evolution of AI, we need to consider as well as the situational awareness based on AI, which will encompass the extraction, the analysis of cyber threat intelligence, along with the early attack warning response recommendation, trying to standardize the information into one format, which will be reusable between different partners and different organizations, starting from academia, small medium enterprises, and national authorities. In order to be more prepared for the cybersecurity, privacy, and business continuity assurance and trainings tailored to original equipment needs. And of course, we should think about the comprehensive technical and economic risk management, which will integrate the information from multiple security assessment and will support the risk-benefit analysis to inform decision-making, either for companies or for national authorities, and for cyber insurance as well. Together with that, one of the important part of Synapse is risk transfer schemes with the smart contract-enabled cybersecurity insurance, which is pretty novel, to be honest. And we're working towards the safe and secure cyber world. In order to develop the tools and mechanisms for sharing and interoperable information. The alerting and reporting mechanism will be also developed to enable collaboration and coordination across different cybersecurity actors from different sectors at the national level of the states and EU level. And of course, we will deal with the adoption of Synapse as a service. This is our ultimate goal, to be adopted by both large organizations and SMEs in order to have the well-established situational awareness, incident response, and preparedness. So, amongst the objectives of Synapse project, we can derive them from the tasks and the goals that we discussed before. So the first one, and one of the most important, is the development of the comprehensive integrated technical and economic risk assessment capabilities, which will cover all the different types of assets, enabling the holistic and advanced management of cybersecurity, privacy, and business continuity risks at different levels, as well as development of trustworthiness, AI-enhanced situation awareness capabilities with the machine learning model sharing support, which will help in proactive response and prioritization of cyber threats. And developing response and preparedness capabilities, which will include the capacity for both cybersecurity orchestration, automation response, and definition and execution of realistic training in order to develop and offer interoperable sharing mechanisms for information exchange, of cyber threat information exchange, and alerting and reporting in different levels of private and public cybersecurity actors. And we think we are going towards the integration and delivering of Synapse platform at technology readiness level 7 in context of 4 pilots. 3 pilots are already the part of consortia, and 1 pilot will be attracted under the open call procedure, which is external to the consortium. And so we will be making our actions towards the maximization of the project's impact, creating, let's say, open and sustainable solution which can be reusable by different partners generally. So Synapse is based activities on the multi-layered approach. If you're talking about the integrated cybersecurity risk and resilience management, we need to think about the models, we need to think about the data on the other hand, and we need to think about the, let's say, core of the project as responsive preparedness and cyber insurance. So the data which is received from different types of assessment, like dynamic and penetration testing, runtime monitoring, vulnerability analysis, user-oriented behavior analytics, and cyber threat intelligence, so on and so on, processed with the Synapse models developed within the project, like subjective risk assessment, asset model certification, vulnerability and monitoring, and penetration testing. And all this information, when the data is transformed to information via the models, is used as an input for developing the response and preparedness mechanisms via cyber range training, for example, or business continuity and cybersecurity orchestration automation response. One of the core elements of this multi-layerness of Synapse is the cyber insurance. So, which will help in formation of the policies, in validation of cyber claims, and with the preliminary analysis of claim data using different methodologies and tools developed within the project. Of course, this will help to achieve the trustable economic risk impact analysis, which will imply both technical risk analysis and economic valuation analysis, then derived by risk identifications based on the questionnaires, based on the subjective risks identification, and using different types of tools for penetration testing, vulnerabilities, user entity behavior analytics, and CTI, apart from others. So basically, we're thinking about this multi-layered approach in order to transform the available data via the developed models, using the tools which are currently under developing within the Synapse project towards the safe and secure cyber future. So the conceptual architecture of the Synapse project consists of the two Synapse instances. They are depicted at Synapse or organization A instance and organization B instance. And part of that, we have external bodies like cybersecurity insurer and different types of national cybersecurity authorities, like national cyclos, OEC oversight, and so on. So basically, cybersecurity insurer has the bidirectional connection within the developed integrated risk management part of the Synapse project, which we imply in itself smart contract handling, economic and technical risk assessment, and security and privacy assurance and certification. And National Cybersecurity Authority has also two bidirectional connections between two Synapse instances in form of national level alerting and reporting. Means that Synapse platform will be able not only to, let's say, harvest the information received from national cybersecurity authorities of different types and kinds, but also send the data in order to alert and inform about the incidents and cyber threats. And two Synapse instances, they are connected between each other and sharing the information, exchanging the information and reporting in different types. It can be training program sharing via development and sharing the playbooks, cybersecurity playbooks, via the sharing of ML models, cyber threat intelligence information, and technical indicator sharing. So this is the main conceptual parts of the Synapse architecture, and itself, both instances consist of several parts, either preparedness with the cyber range training and training repository, instant response and business continuity with orchestration and playbook repositories, and AI enhanced situational awareness, where we're trying to imply the modern mechanism and tools of artificial intelligence in order to help to build the trustworthy data interchange between different tools, and having the repositories of AI ML data models and CTIs, and of course the multi-layered security and privacy monitoring tools like deception tools, forensic, CMs, and others. So Synapse is going to be validated within the context of 4 real-life pilots, and 3 pilots we are having right now in the consortium. And among them, we have 1 pilot from energy storage and distribution domain from Atomic from Germany. We have the supply chain and of public healthcare system, NPS, from Cyprus. And the 3rd pilot is our cybersecurity insurance horizontal pilot, which will touch all the let's say all the other partners as well. So currently we are undergoing the open call procedure, trying to engage the 4th pilots. Within this open call based pilot, 3 beneficiaries will join Synapse through the open call with the financial support. And among them, there will be additional end user providing new pilot, and 2 SME partners covering the cybersecurity supply side of Synapse technology providers. So basically, we will validate the results of and methodologies and tools developed within the Synapse project within the 4 real industrial pilots with the good and groundbreaking use cases. So let's say finalizing the introduction and architecture and conceptual things. Here are the 7 core concepts of Synapse. Among them, multi-layered security and privacy monitoring, about monitor detection response and different types of the tool sets, AI-enhanced situational awareness, which will imply CTI discovery analytics, different type of user behavior analytics, and ML attack prediction and response recommendations, incident response and business continuity, which have the coordinated orchestration, execution of Synapse playbooks, parallel execution of them, and specification of, let's say, production of user-friendly framebooks, which can be reusable, different type of users and organizations, regardless of their level of maturity, integrated risk management, which is about the continuous security and privacy assurance and certifications on different types of standards and assessment of evidence-based security with the core of privacy and resilience. Of course, it's about preparedness. So we're talking about the cyber range and trainings in simulated environment. It is about Synapse smart contracts with transferring of risks and cybersecurity insurance and policies into play based on distributed ledger technology. And one of the last thing is alerting, reporting, information exchange between different Synapse instances, national authorities, and cyber insurance, and smart contract exchanging, and also training program material from preparedness of subsystem. So I think this all the introduction to the Synapse project, and yeah, thank you for your attention. Let's build the more safe and secure and sustainable world. Thank you very much.
Thank you very much, Oleg, for your insightful presentation. Thank you. And now I would like to give the floor to Andrea from Framatome, who will present our first pilot.
Thank you, Tovia. So my name is Ende Jai. I'm a cybersecurity researcher at Framatome GmbH, and in the next 10 minutes, I will present Framatome use case. So we are the first pilot on energy storage and distribution in the Synapse project. And the presentation will cover the description of our infrastructure briefly, also the operational process, and the setup of our testbed, and finally the key NIS2 requirement, cybersecurity requirement, with a particular focus on risk assessment, economic risk assessment. So the objective is also to demonstrate how Synapse and the associated tool will support to mitigate this risk in order to comply with...
Sorry to interrupt you, Andrea. I cannot see your presentation. I don't know if you're sharing.
Yes. Now it should work. Can you see the presentation? Up.
Yes, I can see your presentation, but not in the presenter's mode. I can also see your notes.
Up. Just a moment, please. I will fix that.
No worries.
Yes. No. And can you see the screen now? The slides, I mean?
Yes, that's perfect.
Okay. So as I was saying, the main objective here will be to also demonstrate how Synapse and the associated tool can support into mitigating the risk in order to comply here with the NIS2 legislation and the requirement for the energy sector. So this is the main the use case that we will that I will describe in the next 10 minutes, let's say. And well, our use case is the Covalion hydrogen fueling station. So Covalion is basically a brand of Framatome that specialize in hydrogen fueling station for public transportation. So initially we had a small scale operational plant in Bielefeld in Germany here, supporting 5 buses, but the pilot project provided insight into, let's say, the security requirement and the security challenges for such a business. And building on this, we are now scaling up to a new plant in Essen, which will serve more than 100 buses and also with a distributed system across multiple locations. So, and this expansion will let's say, bring us to a transition from pilot project to critical infrastructure as per the classification in the CRITIS-V from the BSI, the German BSI. So here, how the fueling process works. Basically, we have an hydrogen that is delivered by the Covalion truck here at 50 bars, and then it's pressurized up to 600 bars for storage. And during this fueling processes, the hydrogen is dispensed into the bus fuel tanks at the required high pressure. And finally, the fuel cell system will validate the process to ensure the safety and the efficiency of the whole process. And here, let's say a seamless integration is key to have a reliable operation at the plant site. And this is the representative test bed we designed in the project. So there is basically a simulator that will mimic the operational process of main primary assets from the hydrogen refueling station. And for example, for as main primary assets, we have the compressor, the pressurized hydrogen, and the hydrogen dispenser, and the hydrolyzer. And we also have in our test bed included further the supporting assets, for example, the OT equipment, such as the PLC, the SCADA systems, and also mimic all the network communication between the different assets. And and we have the networking system, for example, the industrial router, the Flexi EVOM, and a bunch of IT equipment, such as also the maintenance computers. And on top of that, we have our Synapse instance. So here, the main challenge, let's say, will be in other term during the operation to be able to continuously ensure the availability of the refueling process. And for that, we are targeting, let's say, 99% availability of the refueling station along the supply chain. And it is crucial to stick to this objective. As any, I mean, we should comply also with the horizontal requirement from NIS2, and to maintain, and we should also maintain and quickly, let's say, resume the critical operation in the event of a cyber attacks. And for example, there is different event that could impact critically the refueling process. So we can have a prolonged outage which will have a high impact on our operation, a data breach from our customer, and this, let's say, have a moderate impact compared to a prolonged outage of more than 4 hours. And here, in terms of also economic risk, there is a potential threats that are identified, and this include the 3 out of 10 of the OWASP 10 threat for OT environment. And for example, malware or ransomware could have a severe impact of 4 billion euro per hour of downtime cost in our infrastructure. An unauthorized access also have something like a 5 billion average cost in terms of economic loss, and denial of service attacks would have something like a $1 billion per minute downtime cost on our businesses. So in this next slide, we map the different attack scenario that we provided in the project to be able to have to measure the potential impact in terms of economic risk of such attacks on our infrastructure. So typically, this is the risk assessment metrics, where we show also that the likelihood of a risk event and the severity, let's say, of the consequences on our business that we scale in a 3 level. And as you can see, when it's corresponding to the previous slides also, regarding the attack scenario. So basically, this is let's say the requirement that we have on such infrastructure to be able to operate it reliably and complying with the key requirements from NIS2. And here, Synapse will offer and provide for our use case, let's say, an economic risk assessment tool. So basically, it will offer model-driven economic risk assessment method processes on different assets on our testbed, and in this case, the primary assets that has a higher value in our use case. And we are also with Synapse will provide in terms of mitigation strategy a real-time tracking of our recovery time objective, and also our RPO that we call recovery point objective. So the RTO is the maximum acceptable amount of time that the hydrogen refilling station can be offline after a disruption. And similarly, the RPO is the maximum acceptable amount of data lost that is measured in time. And it also indicates the point of time to which the data must be recovered after disruption. So the main idea here is to be able to track, thanks to Synapse, the RTO and the RPO during the attack and after the attacks on our primary assets, such as the PLC that we have in our testbed, and also to have alerting systems when such target, let's say, objective are reached. So this I will come to my last slide. So the progress on our use case in terms of implementation. So let's say that the requirements have been translated in terms of UML diagrams, and also the dashboard are under development. And here we are targeting, let's say, full integration of the economic risk assessment tool, let's say model and process and tools in our use case for the R2 version of Synapse. So these are examples of, let's say, the dashboard that we are preparing right now in order to be able to fully integrate the Synapse capabilities for mitigating and also monitoring the economic risk on our use case. Thank you for your attention. So I will pass the floor probably to George for the presentation of use case 2. Thank you.
Okay, thank you, Daye. So just a moment to share my screen. Okay, I hope you can see my screen.
Yes, we can.
Excellent. So thank you. So good morning, good afternoon from me as well. So my name is George Alexandris. I represent Nodal Point Systems. We are a technical provider for software in critical infrastructures, particularly in the healthcare and energy domain. And in this session, I'm going to walk through our second pilot, and this pilot addresses supply chain attacks in the healthcare sector. And as we all know, the healthcare sector is a domain like the energy sector where security and resilience are really, really critical and vital. So first of all, I mentioned the term supply chain attacks. So what are supply chain attacks? Let's begin with the threat itself. So a supply chain attack is it targets a trusted third-party vendor or a supplier in order to infiltrate a larger organization. So in our case, instead of attacking, let's say, a hospital system directly, the adversaries will compromise the tools and the software components or even the deployment processes itself, which are used to run the hospital's IT system. So this is especially dangerous because it can bypass, basically it bypasses traditional defenses, and malicious code can be inserted during development, during updates and software deliveries. And once the target system is infiltrated and malicious code is inside, and malicious executables can also cause damage and also spread silently. So the cost and why we have chosen supply chain attacks, the cost of these supply chain attacks is enormous. It has been estimated that they cause about $80 billion of damage every year. And for one of the reasons, this is probably one of the reasons why it is ranked as the #1 NISA cyber threat for 2030. So these are the impact that a supply chain attack can produce is enormous. So because especially if we're talking about systems which affect a large amount of the population. And this brings us to our next slide. And here we're going to talk about the actual attack target. Now, for our case, the attack target is going to be a public healthcare system, and specifically the general healthcare system of Cyprus. Now, the general healthcare system of Cyprus, this serves nearly 1 million beneficiaries, so the entire population, more or less. And it also is used daily by about 8,000 registered healthcare professionals, which can be doctors, which can be pharmacists, which can be lab providers, ambulance emergency dentists, all the healthcare providers that are responsible to provide services to a country's population. So, and to give you a sense of what scale we're talking about here, first of all, this system, it maintains each of the beneficiaries' electronic healthcare record, so all of the medical history of every person in Cyprus, more or less. It supports roughly, and I think these are a bit older numbers, so about 27,000 visits or hospitalizations per day, and this translates to about 45,000 medical claims per day. And also this means that it clears over 100 million worths of healthcare goods and services per month. And our role, Nodal Point Systems, we are the main designer, developer, and maintainer of the healthcare system. And obviously, if something, let's say, compromises our delivery pipeline, the impact to the healthcare operations would be immense. So here in our scenario, we have an attacker which targets the NPS software delivery pipeline. So this is the pipeline which transfers executable code from our development premises to the healthcare portal of Cyprus. And through this kind of compromise, they can let's say they can hijack the development process, and they can insert malicious code directly into the production servers. Now, this kind of attack can cause huge outages in the deployment infrastructure. It can cause denial of service in production environments, and basically it will result in major disruption to healthcare operations. And major disruptions means that, let's say, hospital staff will be unable to access the healthcare system, patient records, or there will be no more claims processing. You will not be able to get your medicine from the pharmacy. You will not be able to schedule an appointment with your doctor. So, and I'm not talking about more serious stuff like, scheduling of operations. And actually, these kind of disruptions have happened. There are many examples of cases of these kind of cyber attacks in healthcare operations, and especially supply chain attacks. So let's move on to our testbed infrastructure. So in order to simulate this kind of attack, we set up a testbed in our premises, and this replicates our healthcare development environment. So I'm not going to go into a lot of details here, but basically we have a hypervisor, Oracle Linux, and the container engine Docker for virtualization. We use Jenkins for build and deployment. We have Git and PostgreSQL for source code management. And also we have set up firewalls and network monitoring with pfSense and Suricata. We use Wazoo as a CM, and we access the production container host, which simulates the healthcare portal through WireGuard, and we also have an Nginx server which serves, let's say, as the healthcare portal. Now, and in order to replicate the daily operations in the context of the project, we designed and developed a custom simulator, and this custom simulator, its role was to replay basically the daily activity of a team of 5 developers. And this activity was it was not just random activity, but it was based on actual commits, which during the development of the GHS, the General Healthcare System code base, over a 7-year period. So this is as let's say as authentic as it can get. So since you have seen our testbed, now we're going to talk about how our testbed interacts with Synapse. So this slide shows the flow of data. You can see the day-to-day work. This is depicted with the red arrow. And there you can see where developers commit the code, and the code is then built, and it is deployed to the production healthcare portal. This is quite a bit of a simplified diagram. So you have this day-to-day normal development flow, and all of these servers, through which the data passes, they capture logs and activity, and these logs are shipped to the Synapse network. Basically, they are shipped to an Elastic server there. And in Synapse, various components do the processing. So they check the logs and see if they can identify any anomalies, any unusual and suspicious behavior. The shipment of the logs is denoted with a yellow arrow. And so once Synapse has identified something suspicious, it can inform the testbed through commands telling the testbed what to do in order to mitigate the attack. And this is shown through this green arrow on the top of the slide. So this is in a nutshell, in a very, very simplified way, how we interact with Synapse. one thing that I would mention here is the flexibility and the modularity of this particular solution. You will notice that apart from a Synapse command handler, which is for us, it's a custom application which is built to receive and also in some cases send messages to Synapse. There are no other Synapse components in the testbed, which is extremely interesting and very, let's say, flexible because we're talking about a cloud deployment here. It's very easy, let's say, to connect to Synapse through this kind of mechanism. So I will talk a little bit about the benefits of the Synapse solution for us. Now we have I will talk about the attack stages. So we have how Synapse helps us before the attack, during an attack, and after an attack. So before an attack, Synapse offers static and dynamic vulnerability assessment of the testbed. So this happens using we send all the assets that you have seen before. We send them to Synapse, and these are also regularly updated, and Synapse can scan these assets for vulnerabilities. So this is very, very tailored, let's say, to our infrastructure. And it also provides training, and we are particularly interested in training on supply chain attacks, recognizing supply chain attacks, but also for secure coding. And Synapse can provide these hands-on training courses as well. Now, during the attack, as mentioned before, Synapse has a variety of detection mechanisms. Some of them are also AI-based, which can identify this kind of abnormal behavior, and they can identify it in real time. And in our case, and for the particular scenario, if someone starts fooling around with the deployment pipeline, Synapse will be able to detect this and will immediately step in to block this attempt. And this ultimately will prevent any malicious code from reaching the healthcare portal. And finally, after an attack, or let's say an attempted attack has occurred, Synapse can automatically generate an NIS2 compliant incident report and also forward it to the relevant national authority. I forgot to mention here, very important, that for this use case, we're also cooperating with the Digital Security Authority of Cyprus. The Digital Security of Cyprus is a governmental entity which oversees all critical infrastructure in Cyprus, including healthcare. Okay, and more final point about the business operations and what Synapse means to us and also as an SME, because we, in contrast to our partners from Framatome, we are not a large corporation. We are an SME, so we do really need to be very. We need to utilize our resources as efficiently as possible in order to maintain, let's say, both our reputation and also the quality of our work in this very, very demanding governmental sector. So here, what Synapse does for us, it allows, first of all, it's a door, let's say, to obtain cyber insurance. So through obtaining cybersecurity, we can also at the same time obtain cyber insurance. Now this introduces, first of all, this is something that we need, but it introduces very, very big efficiencies. We do not have to go through separate processes and different, let's say, do not need to engage with different entities for cyber insurance, because the platform that protects us is also trusted by the cyber insurance vendors. Is something very, very important. Something else more related to the actual incidents, through Synapse, and because Synapse uses the concept of playbooks, we have a very standardized way of addressing cybersecurity incidents. And this is very transparent and very repeatable. And this again introduces significant resource and cost efficiencies. And finally, even in the case of a claim handling, if an incident occurs, it can be really easily coupled with operational evidence from the infrastructure. Now, this concludes our presentation. So I hope this was interesting. And now I will pass the floor to our partner from Karavias, Mr. Stergios Asteriou. Thank you very much.
Thank you, George. Good afternoon, everybody. I'm Stergios Asteriou from Karavias Insurance, and we will proceed with the presentation of the insurance dashboard. But prior proceeding to this, let me share a very quick presentation regarding the current situation in insurance market. Hope that you are able to view my screen. So, currently, the insurance market status is based on insurance requests, which are, let's say, on a paper process. Synapse aims to introduce a process that insurance requests based on a digital environment. Risk profiling is currently based on prospects insured declarations, while Synapse aims to proceed in risk profile based on comprehensive risk assessment. Incident verification currently is able to be verified after a period of time when Synapse aims to provide instant incident verification via smart contracts. Currently, there is a static evaluation of risk exposure based mainly to insured entities declarations, while Synapse will be able to provide an ongoing evaluation of risk exposure. And finally, the current status of manual or semi-automated insurance policy management will be developed to an automated policy management. So let's proceed now with the dashboard. Dashboard has two main users, the business expert and the insurer. So I will proceed by switching the screen of the two users in order to be able to understand how the basic functionalities are. So the business expert connects to the dashboard, and he provides an insurance request by completing basic company information. For example, here we have a company with the name Health Company, located in Athens, established in 2015. This is the website address. And here is the last complete financial year's gross revenue and net profits. Those figures are very important because upon those figures, the smart contracts will be able to automatically calculate the claim losses depending on business interruptions that will take place for a certain period of time. So the company produces, let's say, 5 million euros gross revenue per year, 1 million net profit per year, and it employs 30 people. It is a privately held company. The contact details of a contact person are also collected. The industry sector, here we have, in our example, a healthcare and social assistant company. It is also very important to define the industry because it defines also the level of the risk the company has. We have also some quantitative and qualitative information that are collected, like the operational expenditure on IT security, the information if the IT infrastructure is in-house or outsourced. In our case, we have selected in-house. And also how many employees has IT department. It can be changed. Okay, we can every single company can modify this information according to it, and also how many of the IT employees are devoted to IT security. Additionally, the company will select insurance coverage. This is a series of insurance coverage. For our example, we have select security, cyber, and privacy liability, and system damage and business interruption. The requested insurance limit is 1 million. We also collect the type of records that the company collects. Here we have personally identifiable information, and also we have health information files because the industry of in which the company is activated is related to health. Also, we collect information regarding the type of assets that the company uses, and also we have an indication of the value of these assets. Moving on, we have a selection of various security controls that may be applied. So the company select those that are applied in this case. And also we have control effectiveness information regarding denial of services, and control effectiveness regarding server application. So we collect all this information from the company. And finally, we have a claims history that is provided, claims history regarding cyber incidents. In our case, we have a selection of no. So as long as all this information is completed, the company submits this information to the insurance company. So moving on to the insurer dashboard. We can see here that the request is received. You can see here the date, the exact time of the submission. And here the insurer has the ability to view the request form. All the information that are already provided from the business can be found here. And the insurer is able now to create an offer for this specific company. So the offer can take, let's say, a virtual reference number. Here is the name of the company. The premium decided is, let's say, 5,000 euros. The policy administration fees 500 euros. The tax also 500 euros. So this is the total payable premium that the insurer offer. Here, the offer can contain many other additional information, as the company period, the policy period, an extended reporting period that may also be included. So the selected covers as the business has provided. The first one was cyber liabilities. for 1 million. So let's say that the insurer approves the 1 million with a, let's say, 2,000 euro success. And also system damage and business interruption, also 1 million. Let's say gain 2,000 euro excess. Insurer can also add here subjectivities or anything that he wishes to be in place in order to proceed with the coverage, and then submits the offer to the business. So the status here is reverted in the insurer dashboard as offer sent. Moving back to business dashboard. We can see that the status changed to offered received. So the company can see here the proposed offer from the insurer, 6,000 euros the payment, and he can accept the offer or reject, of course. And he can also upload the premium payment receipt in order for the insurer to be able to activate the policy. So he can select and upload the PDF, let's say, payment here. Moving back to the insurer. We can see here that insurer dashboard mentions that offer is accepted from the company. Here the insurer can view the payment receipt. He can also view the request that the company sent it. And here the insurer can upload and send via Synapse the insurance policy. So it selects the demo insurance policy that it is attached and uploaded to Synapse. The status changed to finalized, and moving back to the business dashboard. You can see the status changed to finalized. So here the business, the insured company, can download the contract, the policy. And it has also the history and the record of the request that he has sent in order to produce the policy, and also the payment that it is already proceeded to the insurer. So now the policy is active, the insurance policy is active, and also the smart contract is active. And let us assume that the insured company is facing an incident which caused a business interruption. So the company wishes to send a claim to the insurer for the business interruption loss that it suffered. So in the dashboard, can press in the claim request. It selects the type of the incident. He can write here a common, let's say, business interruption, the incident. Can submit the request to the insurer. So back to the insurer dashboard here. Here the insurer can see the incident, and it can also see the actual size of loss, because the smart contracts has automatically calculated the start of the incident and the end of the incident. So based on the annual turnover that the company has declared in the proposal form and is included in the policy, there is an automated calculation regarding the total loss that the insured company has suffered due to this incident. So this was a brief, let's say, presentation of the dashboard. Stop sharing, and I'm passing the floor to Georgia in order to answer any possible questions or clarification you may have. Thank you very much.
Thank you, Sterios, for this great demonstration. So with this, we conclude the presentations, and now we open the floor for short question and answer sessions because we are already a bit out of time. I'm stopping the recording, so please feel free to raise your questions either directly or through the chat.